this is a very good, this is a very good question where they are trying to fool us, right? See, that pressure and temperature, what effect does it have in equilibrium constant? Pressure does not have any effect. Concentration does not have any effect, right?
Yeah.
So catalyst does not have any, only effect is temperature. So we don't have to discuss, we don't have to think about pressure, isn't it? Shall we have to think about pressure? We know. So we have to think about the temperature. Whenever we're having a temperature, we have to mention that this is exothermic in the forward direction. We write exo. In the bottom, you write endo. Agreed. Now, next
Yeah.
we do what? Next we do what? We have to write down the equation Kc is equal to product to the power of stoichiometry by reactant to the power of stoichiometry, right? This is better, right? See, if you increase the temperature, the reaction moves in which direction? Endo or
Right.
exo? Exo or
Exo.
endo? First tell me. If you increase the temperature, this reaction will be moving in which direction? In the exothermic direction, more heat will be liberated, right?
Oh,
Means
yes.
it will be going for a minimization of the change, right? You minimize the change, right? Isn't it?
Okay, so
Yeah.
reduce
It will be going to endothermic direction, right? Isn't it?
endothermic
Right, mind?
reaction.
It will go into the endothermic direction. And in this reaction, the endothermic direction is which direction? Backwards, right?
Back.
Backwards. So backwards means that more amount of which is produced. Tell me, reactant is produced, right?
Reactant. Yeah.
Reactant is produced, right? More amount of reactant is produced, right? So
So the
this will be
equal.
increasing. So
Yeah.
when this increases, the Kc will
Decrease.
decrease. That's the way we have to see. Very good question. I appreciate. This is a very good question, right? Very good question. Right? Is it clear?
Yes.
Thank you. Now, very good, very good. Now, this is a very good question, right? See that Born-Haber cycle hydration I didn't do, right, at that time. So we have to do that. Write down, right? BHC hydration, right?
Okay.
See, we learned what? We learned that what is enthalpy of hydration? What the
Yeah.
definition of enthalpy of hydration? Could you do enthalpy of hydration, Mahin?
Yes, sir. So
What's enthalpy of hydration? Enthalpy of hydration is the enthalpy change. Tell me when?
enthalpy change when
When
what's called one
1 mole of the
mole
gaseous atoms is surrounded
is
by water molecules as infinite dilution, right? This is the thing, right? When
is it
one
produce
mole,
hydrated ions?
yeah, the gaseous ions is surrounded by water molecules at infinite dilution, right? So what the equation look like? X plus gas is equal to X plus AQ, right? This. Is it clear? Did you get this thing right?
Yes.
It's right. Is it clear, sir? Is it clear to
Yes.
you?
Yeah, yes, sir.
So
I got.
that's very important, right? So if you see that when we try to talk about the enthalpy of hydration will be depending upon what? Depending upon the bond which is formed, right, by the water molecule, right? Isn't it? This bond, isn't it? The positive ion, if it is the positive ion, right? What happens? Which part of the water will be getting attracted? Mind, tell me, which part of the water will be getting attracted?
The oxygen. Oh,
Oxygen. See, such a brilliant, such you know everything. You did silly mistakes, right? Right? You did silly mistakes. I like this, isn't it? Now tell me one thing: if the size of the this ion is larger, will the bond be stronger? What do you feel?
uh,
Size of
yeah.
the ion is larger, right? The same unipositive charge in the larger radius and the same unipositive charge in the
Yeah,
smaller
so the
radius.
larger it is, the more positive it will be.
Mhm. The single positive charge is spread over a larger radius.
Oh,
Where
okay.
is the
Oh,
charge density less? This is charge density
oh,
less.
charge density.
So the enthalpy of hydration and lattice enthalpy, both you can write down this quickly.
Yeah.
Lattice enthalpy and enthalpy of hydration, EH. Write down somewhere in your notebook. Is directly proportional to the charge of the ion, right? Fine. And inversely proportional to the size of the ion. Write down, right? Fine.
Yeah.
Clear? Directly proportional to the charge of the ion and inversely proportional to the size of the ion. Have you written?
Yes. It
Is it clear? Is it 1 minute?
Sorry.
Okay, just 1 minute. Give me 1 minute. Just 1 minute. Okay, fine. So have you done it? Have you done it? Lattice
Yes, sir.
enthalpy and is enthalpy of hydration will be directly proportional to the charge of the ion as inversely proportional to the size of the ion. Now tell me, increasing, you didn't underline, right? Mine in the next part, na? Next any question paper you solve, underline. Increasing, right? Now tell me, charge of the ion, if charge of the ion, you're going to find out which is the charge of the ion more.
The
This
most
is
is,
positive, positive. So we cancel out this.
yeah,
Wait. Increasing, they are saying. Increasing, sorry, not decreasing, right?
yeah,
Increasing. Now you have to search for which is having the more 2 plus on the right hand side. You
yeah,
search. Which two options are there? This and this. Is it clear? Is it
yeah,
clear to you? The enthalpy of hydration depends upon the charge of the ion. Lattice enthalpy also depends upon the charge of the ion, right? Higher
yeah,
the charge, more is the attraction, isn't it? Isn't it? Right?
yeah.
If you're having Ca plus 2, if you're having suppose you're having you're having Na plus 1, right? And you're having Mg plus 2, where will be the enthalpy, where will be the bond more of the H2? Can you guide me?
Mg plus 2.
Mg2 plus, right? The charge of the ion will be ruling first, right? Ruling it. And inverse is the size of that. The first see that which charge is most on the right hand side, that will be highest. Which options can you select? These two. We cross out these two. Agreed? We cross out these two. Understood? Clear? Did you get this thing? We cross out these two. Understood? How do we do it? Mahin? Got it, Mahin?
Yes, understood. We cross these two out
We
and
cross
then
these two because this is having what? This is having positive, right? Uni positive, right? Did you get this thing? It's having uni positive, right? Is it clear? Uni positive, right? Clear? Understood? So we cross out these two, right? So from here now to search one form. Now tell me which is the right answer. Don't think about the answer which are now see
Mg2 plus
now,
1 only, the one with
if you
Mg
see the
plus.
periodic table, Mg2 plus and Ca2 plus, we have to compare. Now tell me which is a smaller ion.
The smaller one is Ca2 plus.
Wait. When you go down the group, what happens?
Yeah, so
When you
what?
wait. When you go down the group, what happens? The size of the atom increases, isn't it? So Ca2 plus will be having larger, isn't it? Larger radius. Understood? Did you understand this thing? Now, if you open the periodic table, Mahin, if you open the periodic table, beryllium, magnesium, calcium, right? When we go from top to bottom, what happens? Tell me. The size of the ion or atom
Decrease. Increase.
increases, right? Increases. Mind, please write down the periodic properties there in the Excel sheet quickly. Don't worry, right? Mind, I'll be there. And mind, I'll be sending some. Is it clear? So
Yeah,
this is a smaller ion. So this is the
larger.
larger. So this is cross. Understood? How? With the
Yeah,
right answer, C, isn't it?
yeah,
You don't have to look into the positive answer. You have to focus upon this. How? Understood? How am I doing it?
yeah, sir.
Right now, go down, please. Thank you. Just hold
Yes.
on. Which reaction represents the acid-base reaction according to Lewis theory, but not according to Bronsted theory? Lewis theory. What is Lewis theory? Lewis
So,
theory is what?
no, no, proton
No.
acceptor. No,
Lewis
no, sorry, that's sorry.
lone pair, right? Lone pair
Lone pair
donor.
acceptor, lone pair donor.
Lone pair donors, right? Isn't it? Lone pair acceptors, lone pair donor. Isn't it? Isn't it? So,
Yeah.
which is technically Lewis theory, but not. See, you circle, but not Bronsted theory. This is a Bronsted theory, isn't it? Mind happening?
Yeah,
Agreed. This is also Bronsted theory happening. Agreed.
yeah.
Now I didn't understand. Now see here what happens. See, can you tell me that ammonia is going to NH3, going to NH3 plus 4 plus? What is happening over here?
It's donating a pair
No,
of
no, no,
elect.
no, no. Not donating. Now think what is happening. See the change. Ammonia was there.
It's
Afterwards, we are
giving an
having
H plus.
NH. NH4 plus. What's the change you're having from here to here? Can you see? What species changed? Which species added? Can you tell me?
H plus.
H plus, right? So this cannot be the answer. Understood? Clear? Wherever
Oh,
H plus is there, wherever H plus is given or taken, that reaction will not be there, right? Did you get to Mahin? Understood.
no, but no, like, isn't
Now tell
NH?
me what is Bronsted theory? Proton donors or acceptors, right? Acceptors. So wherever you're seeing that transfer of proton is happening, that reaction will not be there because not according, right? Clear? Did you get my point? Understood. Please ask me any questions.
Okay, no,
See,
no, no,
can
no.
you see over here
It
what's happening
works.
to
It works for according
everybody,
to
everywhere
bronze.
it will working. See here to here, what's happening? Tell me, tell me what is happening from here to
H
here.
plus is only being given.
Given. So transfer of H plus is there, so we cross it. Search here
It's
to here, what is happening? Guide,
no,
please
no.
guide me.
I'm saying these are all for Lewis acid. I kind of swapped it.
Oh, yeah, yeah. Okay. Anyways, so this is it clear to you? This is what H plus is added. So H plus, we have H plus. So no. Here, see, you compare this with this. H plus is getting added. So this is also no.
Yeah,
So you elimination round, we don't have to think about this answer. We tick this answer right.
yeah.
Fine. Clear.
This was fine.
Wow. You did the difficult part.
And
Can you
this,
did you take the screenshot of that question? Mine? Can you take a screenshot of this question quickly?
this
Yeah. And post it. Right. Thank you.
wait, where did, oh, yeah,
Thank you so much. Got it. Now go to the next question.
this,
This is a very good question, right? Read on indicators. Read on indicators. Read on indicators.
yes,
Indicators acid bases as such. Yeah? And you also make a list, right, of the topics, right? You also make a list of the topics, right? Which you feel. List of the
yeah,
topics, right? Make sure that you look it honestly, right? So what happens over here? What's the indicator? Indicator is a species which will be having a equilibrium, right? Will be having an equilibrium. And they themselves are weak. Tell me, acids, right?
weak acid. Yeah,
Indicates are themselves weak acid. So HIN will be in equilibrium as H plus and IN minus, right? But what's the most God gifted thing they're having? The undissociated state and the dissociated state, right? They both will be having different colors, right? Isn't it right? Is it clear to you? Did you get this thing? They'll be having different colors. See, this color A, this color B. Mine is it clear? I mean, color A and color B. Agreed.
yeah,
Agreed. This is clear to you, right? Color A and color B.
yeah.
Understood. Now, next is what? If you add a acidic solution, what happens? Tell me. Which
Then
side the
the
equilibrium shifts? Tell me.
towards the back.
Color A, right? And color A
Yeah,
will be seen in prominence, right? Mine.
yeah,
Earlier, what happens? Both the colors were there equally. Agreed? Equally.
yeah.
I mean, not equally. Both the colors were present and in equilibrium. We don't know that was the proportion, right? Where is the equilibrium
Yeah.
constant? We don't know. We don't know. So what happens? The color A will be seen, right?
Yeah.
Now, if you add a OH minus, what happens? Tell me.
Then color B will be seen
Double
because
B will be seen. This is right.
yeah,
Now, in color A is observed when color A is observed when this is great. This will be greater, right? Not less. See.
so yeah, I took this as less than.
Oh, this silly mistake, right? You have done lots of silly mistakes, right? Isn't it? It's greater, right? Understood. It's greater.
Yeah,
So
yeah,
this
it
is
should be
wrong.
H in more than in minus.
Yes, yes, yes. IND approximately equals at endpoint. No, nothing.
Mm,
We don't know the equilibrium constant, right? Of this, right? Equilibrium constant, right? We don't know.
So no, it
Wait. What is this?
I
At
need
the
my
end point, wait. Oh, yes, 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 yes. At the end point, what happens? Both are at equilibrium, right?
yeah, both are at yeah. So approximately they're the same both.
Just 1 minute. Give me a minute, 1 minute, 1 minute. At the end point, equals approximately equals. Okay.
And so this also is quite a silly mistake. Look,
Hmm.
I've written weak base, weak acid, and I've circled the wrong one. Weak
So we,
acid
we
and
we started from where? See, from 9. This is
yeah,
9.
yeah. I've written
So
also
this is
weak
the
weak acid,
weak base. Ended ish. So we are taking what? We are taking a weak base in the
and we're
below. See,
adding
weak
into a
base.
weak acid.
Quite a silly mistake, right?
Yeah, then this was fine. This was
What are the major products of the electrolysis of aqueous? You have not underlining anywhere. Mind, next time you underline, huh? Aqueous.
okay.
Tell me. How do you do it? You have got what? You have got magnesium 2 plus and Cl minus,
Yeah,
and you have got water also, right?
yeah,
Water. Now they are saying what? They're saying that the major products, right, of electrolysis of dilute.
yeah.
So from these two, who will be going? Water will be going, right?
Water will be going
Water will be going, and you will be liberating what? H2, right? Hmm?
H2 and then oxygen.
H2, right? And over here, dilute. Dilute means what? H2 will be going, right?
Yeah. So
Now,
again,
mine, I can tell you one thing. This is out of the syllabus. Do you know what? You can ask her. Just ask her, ma'am, is 40 type of questions there? It's out of the syllabus because dilute concentration is not there anymore, right? Just ask her once. Send a message quickly.
yeah,
Just ask ma'am that is dilute and concentrated solutions electrolysis there in the syllabus. This is not there anymore. But still, dilute means what? Who is more in number? H2 is more in number. Mine, can you help me? Can you list out the difficult topics and send it to me? Mine.
yes, I'll list them out another thing. I wrote this down on the
Okay.
thing.
Mhm.
So see, this I didn't know how to do. How do I
Okay.
do this?
Just 1 minute. Mine. Just 1 second. Right.
So
Please enlarge the screen. Mine. I'm thankful to you too that you adjusted the time. Thank you so much. Mine. God bless you. Mine. Oh. Mine. Right. Redox. Right. Are you taking notes?
yes, I am.
Please try to take this, huh? Because this will be a turning point for us, right? See, what is the oxidation state of metal A? So we have to see that sulfate ion is what? Sulfate ions. What is the charge of sulfate ion? Mine?
SO4 2
2
minus.
minus. So this will be 2 minus. So this whole compound will be neutral. Agreed. So what will
Yeah,
be A? Tell me, let it be X. So X minus 2 is equal to 0. Remember, X is equal to plus 2. Understood,
yeah,
mine? Fine. So this is plus 2. Now, this is the activity series of the metal, right? We have to go for the displacement reaction, right? Right? We could go for a displacement reaction. Can you cut paste this question? We to go for a displacement reaction. What does the displacement reaction tells you? That more reactive elements will be displacing the less reactive elements. Agreed, right? Hmm? Agreed, right? Fine. More reactive elements will be displacing less reactive elements. Agreed. Fine.
yeah,
Is it clear? So
yeah,
that's very important that if you see that more reactive elements will be displacing the less reactive elements, right? Clear from its compound, right? Clear?
yeah, yeah.
Agreed. So now tell me, if you react, you cannot understand where tick is given reaction occurred and case no reaction occurred means okay, metal A with this, right? Metal A with this reaction occurred. Yes.
Yeah.
So which is more reactive, A or B? More reactive element displaces the less reactive elements from its compounds, right?
So
Zinc
B.
will be displacing copper sulfate from its compound. So zinc is more reactive, right? It agreed. Understood. If anything can displace other from its compound is more reactive. Which is more reactive, zinc or copper? Zinc. What's the theory we apply? More reactive element displaces the less reactive elements from its compound. Agreed?
Yeah.
Fine. More reactive elements, right? Hmm. Displaces, tell me, the
The
less
le-
reactive elements from its compound. Agreed? Fine. Did you get this thing? Fine.
yes.
Understood. Did you get this thing?
Yeah,
So
I
zinc
got.
is more reactive. So A displaces, does it?
Yes.
So A is more reactive. So you write down that like this, A on top, and B little bit you give a space to it, right? This. Now next is what? Fine. Did A displace C?
No.
No. So which is more reactive? C or A?
So A is more reactive.
Wait. More reactive elements displace the less reactive elements from its compound. See?
Yeah, but so C is more reactive. So
So you write C up on the top, isn't it clear? Agreed?
yeah.
Now next, guide me. Did A be able to displace D from SO4? Yes.
No.
Yes. See?
Oh yes. Yeah. So
So
then A
A
is
is more
more.
reactive. So A and B, D you write. I don't know that how D and B is placed, right?
Yeah.
Now, did A be able to displace E?
Yeah.
Yes. So, right, A is more reactive than E, right? We have got this. It's a
Yeah.
good question she has sent. I don't know where did she pick up from. Okay, now now
So
let's
just
check.
one second.
Yeah. Now let's, yeah, tell me. We have to now compare these, right? Mine, these. Hmm. This series. We have already got A is above A. Sorry, C is above A. We know this.
Yeah, sir.
Now you have to compare these now. This status were unknown, right? So now
Yeah.
go to E. Wait, go to D. Tell me
D
D and the EESO4. Which is more reactive?
E.
Think.
No,
Did
E is correct because it
D is displacing E? Can you see this? It reaction happens. D
yeah, so
displaces.
D is more
More
reactive.
reactive, yes. So write down over here. D is more reactive than E. We got this trend. Understood. Now
Mm.
we have to get a check of a B also. Now B is displacing D. Can you see this? Is
Yeah,
it? Is
it is.
it? And it is also displacing E. Understood.
So that means B is above D and E.
Ah, D and E both.
Yeah.
So how is the reactivity? Is C A? We have confirmed this C and A now.
Yeah. C A.
And after that B D E. Interesting question, right? Understood. Clear.
And yeah.
We have to go to the redox part. Don't worry, huh? I'm trying to redox part we did long back, right? Thank you. Thank you so much. Go to the next question.
Then reduce the activity series. Like this
We
is
have
what we.
got it, right? We have already got the,
Yeah. And then
wait. What's the reactivity series? Please tell me. C
C A
A
B E.
B D E. Huh?
Yeah.
Fine. Take a screenshot of this page. Can you write down somewhere C A B E D?
I'll take a full
C A
screenshot.
B C A B D E. You have to take a screenshot.
Can you go back
Can
to?
yeah. Can you just make it a little bit okay? Fine. Just take a screenshot of the entire question.
So I took a. Oh, wait. Yeah.
Yeah,
This
yeah,
is
like
a
this.
C A B D E. Yeah.
CABD. Huh? Now enlarge this part now. Enlarge. Mine,
Yeah.
you try to take your analysis also and send me by tonight while you're sleeping. Send me the list of the chapters, right? Fine, mine. Send me the list of the chapters, right? Understood, mine. Send me today, slowly. What chapter you thought that would be better, right? To start with. Now CABDE. Huh?
Yes,
Now
sir.
they're asking me that label the direction of the flow. What is saying? Greatest electromagnetic force. What is the greatest electromagnetic force will be obtained if you take the largest difference, right? Is it clear? Agreed.
So same
Largest
E.
difference, right? Is it clear? More the difference in the electrochemical series, more will be the voltage. Agreed. More will be the voltage. Agreed. Did you get this thing?
Yes,
If you
sir.
take A and B, this will be a small. Can you tell me that which will be giving the smallest particular voltage? Which will be giving the next highest particular voltage? Huh? A and D. Understood? And the
A.
smallest A and D
Smallest.
will be no next highest. Smallest will
Oh,
be A and B, or
yeah.
D and B and D, or C and A. Understood? Clear? Gap. More the gap, higher will be the voltage. Agreed? Fine. Did you guys sing? So you have to take what? CSF4 and ESF4 and agreed. Now we have to tell that which this is the they're saying that the direction of the electron flow and mine always try to always draw the anode on the right hand side, right? Did you get this thing? So anode always draw in the right hand side, right? Sorry, left hand side, my bad. Anode to cathode it is going, right? The voltameter, the cathode.
Yeah.
Now what happens? Anode, now write down this thing. In the voltaic cell, you have to take the more reactive in the anode, right? Fine.
Yeah.
Wait. Hang on. Yeah, anode you have to take C. SO4, understood.
Yeah,
Which is the least reactive? At the cathode.
E.
E,
So
SO4, understood. Then you have to take E metal and you have to take C metal over here. Now, how does the electron flow? From anode to cathode.
from anode to cathode.
Anode to cathode. Now, mind, can you tell me that which chapter do you feel that is most challenging for you?
So this only voltaic and electrolytic cells.
Send me a message that challenges in the exam WhatsApp group. Send me.